draw anything right now. That's good. Now, first of all, those guys who are attending this session for this Kafka, you should have at least some idea on how to develop applications by using Spring Boot. Okay. First, you should have an idea on how we can able to develop the applications by using Spring Boot. Because we are going to implement this Kafka concept by using Spring Boot. Basically, Kafka you can understand even though if you have no knowledge on Spring Boot or microservices, but you can understand the concept of this Kafka. You can understand the concept of the Kafka, right? Now, but when it comes to implementation part, I'll be providing the implementation by using Spring Boot. Okay, so for today's session, okay. And one more thing, I need to give a welcome to you. That's why I want to say welcome to Ashok IT, our organization. And second thing, somebody is asking about in the chat box, like how many days it will. It will be around 3 to 4 sessions. That's it. Okay, so today I will be talking about what is Kafka, what is the importance of Kafka. Okay, what is the traditional systems and what are the Kafka systems and how they work. So basically, we are going to have some example way of understanding about Kafka's importance and why it is most important. Okay, that is what we are going to discuss in the session for today and how it works. What is the Kafka's architecture? If possible, I'll add today. Okay, I'll be explaining about all Kafka basic things. First, we are going to understand. Okay, right. Okay, so that's the first thing, guys, we are going to start with. Okay, Kafka. We are going to discuss about that. Okay, let's start. $15 is good. See. First of all, we want to talk. Okay, we want to discuss this Apache Kafka. First, we want to discuss what is the importance of Kafka. Kafka is a stream-oriented or message-oriented platform. So in order to understand what is this message-oriented platform, first we need to have some discussion over there, right? So that we can understand. See, we will be taking some examples to understand about the importance of Kafka. Okay, basically Kafka is a one streaming platform, which is a distributed streaming platform. So before I talk about that, first of all, suppose if we want to provide a communication between two applications. Okay, if I want to provide communication between two applications, what are the different possible ways are there in order to make the communication between the two applications? Okay, correct. So can you guys guess what are the communication ways or what are the ways that I can able to communicate between one application and the other application?
So one is the API and one other is the streaming channel.
Through HTTP protocol, we can do communication also, and another way of like is Kafka.
Pinch client.
Okay.
Microservice in client REST template.
Yeah, microservices.
REST
Okay.
template, web client, pin client.
Okay. They are microservices. If you want to call the REST APIs of the other service, then you are going to use those three types. Okay. Basically, you can understand. Okay. The thing is now, see, requirement is we want to, okay, we want to provide communication between two applications. I'm not talking about just only microservices point of view. Any Java applications you take up. Suppose you want to provide communication between two applications. There are three possible ways we have. Okay. One is a remote procedure call, which is called RPC communication. Between two applications, I want to provide communication, right? Suppose if you use a REST template or pin client or web client, whatever, that is only to make a call to the REST APIs. Okay. I have a client application, I have a server application, but server application is not a REST API. Okay. So REST API is one way of communication. In my three, see, suppose if you want to provide the communication between two Java applications. If you want to provide the communication between two Java applications. Suppose if you want to provide communication between the two Java applications, we have three ways. One is use RPC mechanism. RPC stands for remote procedure call. Remote procedure call. Basically, the technologies like RMI and EJB have followed this, the previous technologies we can call. Okay, when there was no REST APIs, but there also we have a communication between a client application and a server application. The communication between the client application and server application that was made with the help of RPC. RPC stands for remote procedure call. Okay, that is the one. Now, once REST APIs got implemented, and even before REST APIs only, we have one more type of communication got available, and that is called as message-oriented communication, which is called message-oriented middleware. In shortcut, it is called MOM, M-O-M, through MOM, message-oriented middleware. Which is in shortcut called MOM. Okay. At that time, we don't have Kafka, but we have a API called JMS, Java Messaging Service. Okay, Java Messaging Service, which is called JMS. Now, third, we have the REST API. REST clients or whatever it is, okay? Simply REST APIs. Through REST APIs, we can able to provide the communication between one and other. Okay. So suppose if you want to provide the communication between two Java applications, of course, REST API can be used to provide communication between heterogeneous applications also, which is called interoperable communication, which is nothing but the client application, server application may be onto different languages, but still we can able to provide the communication. Now, we have something called as a remote procedure call, RPC. Second one is message-oriented middleware, and third one is REST API. Okay, so in that we are discussing about the message-oriented middleware. So the one way of providing communication between two applications is by sending and receiving message. Message-oriented middleware means there is a middleware which can store the messages, and applications can send and can receive the messages. Through sending and receiving the messages also, communication is possible between one application and other application. Of course.
Sir, In
The
RPC,
first
what is
asynchronous, okay, you have to listen. Okay, the first asynchronous communication that is made between the client applications and server applications is message-oriented middleware only. And before that, we have all synchronous communication only. We don't have any asynchronous communication. If a client makes a call to the server has to send a response back to the client, and till that time, the client has to wait, and no way that a client can go forward without getting response from server, either a response or an exception, whatever it is. That is a synchronous communication that we have. But later on, with messages communication only, we got the concept called as message-oriented middleware. So where asynchronous communication is possible, what does it mean? Suppose a client can send a message, the message gets stored in somewhere in the middle, and the receiver application will come and collect the message, will process it, and in response again you will send a message. That message, that producer application will receive it. This is where you got the words called producer application and consumer application. Like that, two types of applications we got. And this is where asynchronous communication is possible. That is called message-oriented middleware. In shortcut, it is called MOM. And we are also now going forward to understand about this MOM only, because this Kafka is also message-based communication only, but which has advantages like scalability, fault tolerance, and all. So we are going to understand that why it is a big, it can handle some millions of messages per second. So that's where Kafka has got more popularity, and we are going to understand that. Okay, but basically, with messages, applications can able to communicate with each other. That is where message-oriented middleware softwares are introduced, and there are plenty of softwares are available: JMS server, RabbitMQ server, WebSphere-MQ, and now it is Apache Kafka, and we will be having, I think, something called Pulsar. So different the middleware softwares are available. This Kafka comes under that MOM software only, which is called as message-oriented middleware. Okay, that is a clear-cut clarity on how the communication happens in the messaging-based applications. What happens now? Producer application will send a message, and that message gets stored in the middle. We can call that middleware as a topic or a queue. Then there is a consumer application which is registered to answer these messages, and that will collect, that will process it. In response, again, that will send a message that will be collected by the producer. So in reverse, consumer is going to become like a producer of the message. Producer will become the consumer of the message. That's how the communication takes place. That's called message-oriented middleware. Okay. So let me add. Okay, this is called message-based communication now. It is not a direct call. Okay, with REST APIs, nowadays you have APIs like synchronous communication, asynchronous communication by using web plugs, that is called reactive programming. So where you have asynchronous communication in the REST APIs also. Okay, but the first REST API asynchronous communication was made possible by using messages only. So in MOM means message-oriented middleware. In message-oriented middleware, the applications are going to send and receive the messages through a middleware. The applications, who are the applications here? Client and server. Otherwise, we can say something called one as producer and other one as consumer. The applications like producer and consumer. The applications like producer and consumer can send and receive the messages. This is what in the MOM. The applications like producer and consumer can send and receive the messages. And the communication made between the application and application. Producer is one application, let's say client application. Consumer is a server application. Assume that. Between two applications, we want to provide communication. Let us take an example to understand how this producer application, how this consumer application, I'm going to tell you. But there are two types of applications are available whenever we are talking about the message-based systems, like in Kafka also. When we are going forward discussing about Kafka. So in our Kafka also, there is a producer application, there is a consumer application, and Kafka is a server in the middle, which can store the messages and which can share the messages, whatever producer has given. it is just going to share it with the consumer, and whatever consumer is replying, that will be shared with the producer. Just it is acting like a middleware software. That's why this basic point is going to give more clarity on the next upcoming Kafka. Right, okay? Applications can produce and can consume, that's called send, and receive the messages. For that, in a middle one software is required, that is called MOM software. Kafka comes under one MOM software. Like that, multiple MOM softwares are there, but Kafka has more importance because of its scalability. It can handle for its fault tolerance, okay, and it has its own features. Of course, we are going to look into that. Okay, then we'll discuss about what are the terminology that we have. Okay, right. Its throughput, its infrastructure. So these are all makes Kafka as a unique out of the available message-oriented middleware softwares. So what happens here? Producer will send the message and consumer will receive the message. In the middle, there is a MOM software available. So I'll of course draw in the form of a diagram so that you can understand. And consumer will collect the message from that particular MOM software. And in that MOM software, to store the messages, there is one object. And that is actually called as a topic. Queues and topics are there, but queues we are not going to see because that is point-to-point communication. That is one producer to one consumer only, one-to-one communication. Okay, right. So the communication is asynchronous. How it is asynchronous? See, producer is going to send message not directly to the consumer. Producer is not sending the message directly to the consumer. We have a plenty of examples. We will see one by one, like your Uber, like your Ola, everything is this one only. Okay. And your e-commerce applications, anything you take, even a restaurant accepting your order in Swiggy, that is also this all are going to use a lot of this type of MOM infrastructure. Okay. So the point is, while producer is sending a message, it is not directly sending to the consumer. And when consumer is receiving the message, it is not directly going to receive from consumer. Right. So producer just sends message. The message gets stored in middleware. At that time, it doesn't know whether the consumer is available or not. Like dropping a letter in post box. Okay, when you are sending a letter to your relative, you don't know whether relative is available at home or not at that time. Just you're dropping a message, you're dropping one letter in the post box. Okay, so that is at the time of producer is sending a message, it is unaware of, first of all, even who is the consumer also. In post box example, consumer we know, means because we are writing our relative address on the letter. But in producer consumer communication, producer don't know about who is the consumer doing this, processing this message, receiving it and processing it. Just it will drop message and it will continue the work. It will continue its work. Okay. In a large scale systems, different applications will be there. Each application will take care of one type of work. Right. For example, there is an example that you guys need to understand. For example, okay, I'm a dealer of Royal Enfield showroom. I am a dealer of Royal Enfield showroom. Okay. I'm a dealer of Royal Enfield showroom. When available stock is less, I need to put one order. Right? I will put an order to the company. Okay, a message is sent. Okay, these many vehicles of these models I need as my stock is low. So my system is going to send a message to the company.
Hello, sir.
That's it.
Sorry to
But
disturb.
directly it is not going to send message to the company.
No.
Okay, it is not directly going to send any message to the company. It is just going to send a message to the middleware. From there, the company application will receive it, will process it. Later, it will give response, maybe at evening, or maybe immediately, or maybe at afternoon, somewhere. I kept message in the morning, let's say. My system is setting message like that. And in the evening, it may give response saying that, okay, okay. So all the doubts I'll explain only at the end of the session, okay? Because in the middle, you should not disturb the flow. You just write all
are you
your
sharing
whatever the
something?
doubts
We
you
are
have,
not
just
seeing
keep
the
it.
screen.
All
Sir,
your
your
doubts, whatever you have,
only
just keep it
notepad
in your
screen.
notes.
Sir, only notepad screen is visible. Are you drawing somewhere else?
Nothing. I'm not drawing anything. Okay. I will
Okay.
everything visible to you when I'm drawing. Okay. I will draw.
Okay.
Currently, I'm only explaining. Okay. Right. Good. See here. So thing is, I'm just explaining. First, visualize yourself in the air. So then later I will draw. So that's how the communication takes place. So while producer is sending message, consumer don't know you are sending the message. Or at that time, maybe consumer is running or not, even that also you don't know. That's how the message communication takes place. In message oriented systems, it will happen like that. Later, consumer will receive it, will process it, and then will send a reply. Okay, your order is accepted or placed, or okay, we are ready to deliver, or sorry, we will deliver after a week, something like that, based on the inventory. That's what I'm trying to say. So my point to write here is, some points I'll not write more points here. Some points what I want to write is producer and consumer. Producer means an application. Consumer means another application. How these two are communicating with each other by using some message. So I'll tell you how it is going to work. Okay. Producer sends the message to an object which is called topic actually, or we can say mom server, we can call anything. Sends a message to a topic. Topic is nothing but an object where the messages of the topic are stored. Each topic will have a unique name. I'll tell you what is the meaning of it. Producer sends a message to a topic. The consumer, I'll draw the diagram for this. The consumer will receive the message from the topic, will process it. After processing, whether it is going to send response or not, okay, that is secondary part. It's not compulsory that consumer must give a response. Okay, maybe it is going to process it. It is going to store that information in the database. In that case, it is no need to send any response or acknowledgement back to the producer. The communication is producer and consumer. I'll give you the diagram. Producer and consumer, not necessarily known to each other. Producer and consumer, not necessarily known to each other. They don't know each other necessarily, not necessary. Which component is sending this message, which component is receiving and processing it, it is unknown. Producer and consumer, not necessarily known to each other. And one more thing I want to write here is what? Producer the communication between them is asynchronous. Okay, how is asynchronous? Producer doesn't wait. It will send a message. It will start continuing its, it will further continue. It will further continue its operations. Later, consumer may respond. If a consumer responds, then producer will have a callback, and that callback will execute automatically whenever if a consumer is replied. But producer is not waiting for the response from consumer. Just I want to write that message, then I'll draw the diagram for you. Producer will send a message to a topic. We'll understand what is topic. Okay, producer will send a message to a topic, then continues its work. Further, by without waiting for okay, then continues its work further by without waiting for the response from the consumer. Now let's see in the form of a diagram how it is going to be. I can paste the diagram or to check it, otherwise I'll move to MS Word doc. See here. Okay, I'm just going to draw the diagram for you. See, what I'm saying is this is a producer application. Consider this as a producer application. Let's name it as a producer application. You guys can see this. Okay, done. So this is producer application. What it is going to produce? Sorry, it is going to produce a message. Let's say this is a message. It is going to create a message and it is going to send a message, right? So this is message. This message is nothing but could be string, could be some integer value, could be double value, could be Java object. This message can be anything, right? This message can be an object, right? Order object or a customer object, whatever it is. It can be an object also. Okay, this is message. Like I'm drawing it like envelope. This is a producer. This producer creates this message and will send it. This will be stored in the middleware. This is the middleware infrastructure. Okay, in the middleware to store the messages, there will be one object. That object will store the messages topic wise. Topic wise in the sense, there will be a topic which is an object. There can be multiple topics also. This is an object where messages are stored. The only requirement to provide communication between producer and consumer through messages is both must be registered with the same topic. This is the MOM software, middleware software. MOM software. I'm calling this as a topic. It is a place where the messages are stored. It is an object in the MOM software. This is a message gets stored here. Okay, producer will create the message and will store it in the topic. This is called a message. I'm calling simply MSG. Producer creates it and stores it or sends it. That is called publishes it, any word. Okay. The only thing is what to provide communication between producer and consumer applications through messages. When we are designing our application, they must be registered with the same topic. Now there is a consumer. Let's create here. It creates message and sends the message to topic. Creates message and then send it to topic. Now there is consumer. This is consumer application. We call it as consumer. Now this consumer, it is also one application. We are going to create producer, consumer using Spring, but right now this consumer will connect with the topic. Already it is registered with the topic and will collect the message as and when it arrives. Or the consumer may not be available at that time when the producer has sent it, because the message gets stored in a middleware. Consumer can later, when consumer started, it can connect with the topic because it's registered with the topic already. It will collect the message from the topic, which means I'll use the kind of arrow like this. This consumer will connect with the topic and he will receive the message. Message delivered to the top consumer. Consumer is going to receive it and then consumer will start processing it. I'm just drawing. You can understand this. This is the message. Okay, this is get delivered. Now consumer received it. That's how it works. This message can be anything. Could be an object of Java. Could be an order object that a producer is placing an order. This order is constructed as a message and stored in a topic. Consumer is going to receive the order. First, it is going to connect with the topic. Of course, it's registered with the topic already. So it is going to get the message from the order from topic. It will process the order and it will again place a message. Maybe at that time, consumer becomes producer, producer becomes consumer. That's what I'm trying to say. This is a diagram in which you can understand. I think I can't paste this diagram in Notepad, so I will do one thing. I'll open MS Word. Look at this. Then later I'll share this doc with you. Okay, right. So now I think you guys got clarity on this. Next, we'll have examples to understand it. Okay, that's how it works. But one thing, sometimes there can be multiple people can receive, multiple consumers can receive. Of course, I've given the diagram one consumer. there can be multiple consumers registered with the same topic to receive the messages. That is called one-to-many communication. Like for example, you have a Tata Sky set-top box. You are using it to watch the channels. Okay. When Tata Sky application has sent any message, then it will be received by all its subscribers. Suppose Tata Sky has sent a message. Okay, this is the upcoming offer in the Tata Sky. You register for 1 year plan, you upgrade to 1 year plan, then we'll give you 2 months extra. You can subscribe for 2 more months extra. Suppose Tata Sky is a message producer, right? When they publish the message, then what happens now? All the Tata Sky consumers, subscribers, we call them, all the subscribers of the Tata Sky will receive that message. For example, I am also a subscriber of Tata Sky. I am also using the same. But right now, my Tata Sky set-top box is switched off. They have sent a message, but it's switched off. Maybe tomorrow I'm going to switch on. So as and when I switch on my set-top box, and I will receive that message. So directly, Tata Sky is not sending the message, this offer message, directly to the each set-top box, right? They are sending, and that gets stored in some server. That is one message-oriented server. Message is stored there. And there are all Tata Sky set-top boxes are subscribers. And they are all connected with the same topic. That's why they all receive the message whenever it arrives. If suppose any consumer is right now is not, if any set-top box is currently not in running, it is switched off. And whenever it's switched on, it will connect with the same topic and it will receive the message whatever is arrived from the topic. That's how the communication. That is called one-to-many communication. Means Tata Sky is publisher, which is publishing one message, but there are more subscribers, some lakhs of subscribers. They're all called consumers of the message. That set-top boxes are consumers. That this communication happens through messages only. This is called message-oriented communication. Right. And suppose if you are interested, they will say that what from your registered mobile number, say yes, type yes from your registered mobile number. So that is okay. But how they are publishing their message and how it is reached to all the subscribers. First they will create message, then they will publish it. That published message gets stored in the middleware. Then all the subscribers, they are called consumers. They are going to connect with the topic. They are already registered with the topic because set-top box is their set-top box only. Okay, right? So why when Tata Sky is publishing the message like this offer, why Airtel set-top box is not receiving it? Okay, because their middleware is different, their mom software different, or their topic is different, and this topic is different. Okay, so this is the one-to-many communication, and we need one-to-many communication only. Earlier we have one-to-one communication, but we don't require one-to-one communication. We need one-to-many communication. Okay, let's see now the examples. More examples I'll give you now, so that you can understand why. Now we are going to understand. Suppose if messages are millions of messages per second. Okay, now I want to tell you what are the mom softwares available. There are two popular MOM softwares are available. Of course, there are other. One is RabbitMQ in Java point of view. And the second one is Apache Kafka. Now we are going to slowly enter into Kafka concept, okay? Right. Then I'll give you a lot more examples in understanding it. Not just only Tata Sky. There are many examples are there. All our e-commerce applications, all our ride sharing applications, all. See, I will tell you. The two popular, the two popular, okay, MOM softwares. For Java. One is RabbitMQ, message queue, MQ. Second one is Apache Kafka. Got it, right? The two popular MOM softwares are, one is RabbitMQ, second one is Apache Kafka. Okay, we'll find the difference like RabbitMQ, Apache Kafka has plenty of advantages over RabbitMQ. I'm going to talk about that, okay, because slowly we need to enter into this Apache Kafka. Okay, right? See, okay, basically RabbitMQ is good for point-to-point messaging. Point-to-point messaging means one producer, one consumer, not multiple consumers. Okay, right. See, this producer consumer is not a first concept that you are learning. Okay, right. You know, at villages or even at towns also, people are what, you know, distributing the newspaper every day in the morning, or even milk packets also distributing. Okay, if you have taken their subscription, they are delivering. Right, okay, they are delivering. Okay, for example, Country Delight you are getting, right? So it's a general example. For example, you took the Country Delight app and Country Delight subscription for a month, for example. Then Country Delight is a producer of the milk. Okay, and there is a area-wise distributor in the middle. Right, okay, so that distributor is near to our place. So our address is registered with the distributor. Means we are registered consumer at this distributor. So Country Delight will send milk to that distributor through some transportation mechanism. And that distributor, because we are registered with the distributor, and that distributor is actually going to, whenever the milk arrives, they are simply going to deliver it at my doorstep. Because we are subscriber. We have subscribed that Country Delight. That is general example. I mean, but coming to software. Okay, there are not only one subscriber will be there for Country Delight, right? That is called one-to-many, many subscribers. This distributor will deliver the milk to all the subscribers in that area. Okay, so that area is called, that distributor area is called one topic. Like that, there may be in the Hyderabad city, many distributors are there. Means different topics. Okay. In that way, you can understand. And actually, when the Country Delight app is sending milk, okay, at that time, they don't know whether I am available at home or not. Means what? This consumer, this subscriber, this customer is right now at home or not, they don't know. Okay, they don't know whether I am available at home or not, or my door is locked. Means what? producer don't know whether consumer is available right now or not. It will simply publish the message. That gets stored in the middle. Later, when consumer is live, okay, when comes to live, then he will consume it. Okay, so that's how it works, na? The same thing here also. Okay, so there are two popular softwares are available. What are the two popular softwares? One is the RabbitMQ and second one is Apache Kafka. RabbitMQ is good for point-to-point communication. Point-to-point messaging means, like, one producer and one consumer only for that. That is called point-to-point communication. One message is sent and only that received by one message on one subscriber. Like it is nothing but what in WhatsApp you are sending the message to your friend, not in a group. Suppose you have a friends group also. Suppose if you publish a message, for example, from Ashok IT through our WhatsApp group, we are publishing a message and all the students who are registered with that WhatsApp group are receiving the message. And at that time, we don't know whether your mobile phone is switched off or switched on. Right? So we are publishing the message in the group and subscribers are going to receive it. Right? If, for example, your mobile phone is switched off at that time, whenever you switch on, you are getting back the message, right? Your WhatsApp messages are getting like that only. Whenever you switch on or whenever you come to network coverage area, then you will receive all the messages. So where is the message stored then? While I'm sending the message to you personally, your phone is switched off, your phone is not available. Okay, then where is the message stored? Even I'm not bothering about are you in the coverage area or not at that time. I'm just sending the message to you and I'm guaranteed that definitely you will receive it now, otherwise later whenever you become available. This is all systems developed by using this type of message oriented middleware only. Okay, so these are the very clear examples because WhatsApp every day we are using. So in a group message, what happens if one person in the group is sending the message, then all the group members are going to receive it, the entire group. And that is actually called as one-to-many communication. It is not one-to-one. It is basically called one-to-many communication. Like that, we'll be having one-to-one communication and one-to-many communication. Hope you guys are got the clarity on this point. Next, we will be looking forward. So there are two popular softwares are available, but our software is what? Apache Kafka. Okay, then why should I use Kafka? RabbitMQ is okay for small applications, that too when there is a point-to-point communication. Not point-to-point is one model of communication. Publish subscribe is one other model of communication. Remember in messaging, okay? Means one-to-one communication and one-to-many communication, better simple way. RabbitMQ is good for one-to-one, but slow for one-to-many. Okay, that is also one software, RabbitMQ software. That is also from Apache only, Apache RabbitMQ. Apache Kafka, Apache RabbitMQ, both are given by Apache only. Okay, right. See, we are also going to call this message oriented middleware as a these mom softwares are also called as message brokers. RabbitMQ is called one message broker. Apache Kafka is another message broker. Remember that. Okay, right. Understand clearly. Let's take up an example in understanding about later. Then I will talk about the what I can say the terminology. Okay, and lot many things, of course, about the Kafka architecture, partitions, leaders, followers, many things are. That's what in the first 1-2 sessions we are going to discuss about completely the knowledge of Kafka. Okay, so far I feel that you guys got an understanding of, okay, what is this message broker or message oriented middleware software. They are also called as message brokers. Okay, let's see. Say for example, you imagine, okay, suppose if you imagine an e-commerce site where you have millions of users. Okay, and you know, every product what you are viewing, or every click whatever you do, for example, in the e-commerce application, every click what you do, that will generate an event. Event means some action made by the user, that is called event. When you click or when you add some product to the cart, you want to add one product to the cart, you want to view the product image, or you want to purchase now, you want to place an order, that everything is called event. That word is actually called event. Event means every action done by the user, that is called event. Okay, so suppose if you try to store all these events in a database, okay, then you know, your system will be under what I can say is a lot of load. Okay, right. Because you can't store, okay, you cannot store all these, okay, like when you click store this record in the event in the database, and whenever you add to the cart, immediately stored in the database, or whenever a customer is trying to place an order, then again store. You should not do these many store. You can't store this type of data in the database, because you know, you have millions of users, and you may be getting some thousands of orders per second, or sometimes millions of orders per second. Okay, right? So there we need, everything is not possible to store in a database. All these events we cannot record directly. We should not try to send all these records, all these events. Events is nothing but one record generated, like this user has clicked this product, or this user has viewed this product. So that entire information, that user ID, product ID, everything, that is called one record. That is called event. So you should not store all of them directly into the database, because there are millions of users and you can't store like that in the database. It's not enough. Okay, right? So then you need an alternate to store somewhere these records, and then to process them. We need some middleware required, that is called message oriented middleware. So these events are not directly stored into database, they are stored into one message oriented system, one message broker. Actually in the real time we are going to use Kafka. Okay, because there are multiple consumers are there, because millions of users are producing the messages, and to handle this type of throughput, to allow to store millions of messages per second, and to allow the consumers to process them by collecting them from the broker, we need such a kind of highly scalable system required. And that is where Apache Kafka came actually. RabbitMQ is not possible for that. It's good for point-to-point communication, or when applications are not having high throughput. High throughput means, you know, reading, writing messages, millions of messages per second. That's called high throughput. And you need you know, highly reliable and highly scalable storage system, right, to store this data. That's where now Apache Kafka got introduced. What happens in Apache Kafka? It can allow millions of messages per second to write. into their topics. And it will allow millions of messages to be read by the consumers per second. It will it is it provides high throughput. It supports high throughput. That's a big thing. Let us take, for example, because every day that we are working with what we can call, ride sharing. Okay. See, I'm just giving you an example of, understanding it. Why Apache Kafka? That's what I'm trying to focus here. Okay. Look at this. I just want to talk about, because every day we are working with Uber, Ola, Rapido, like that. Okay. Suppose you take how these ride sharing applications are working, their location tracking and their matching system is working. Okay. See, mostly what, for example, there are drivers are there, riders are there, correct? In any ride sharing app, drivers, riders. These are the two main people. Let's understand how this message oriented system like a Kafka is the one distributed. I'll tell you, distributed means we can make a cluster of Kafka servers. Okay, means one Kafka server can run at one location in the network, other Kafka server can run at other location, like that. We can say broker 1, broker 2, broker means server here, Kafka broker. Okay, will run, and they are formed like one cluster. Means to allow fault tolerance, means by chance if one server fails, then the messages can be stored and can be read from another server in the cluster. This is actually basically used for fault tolerance, to make our system more reliable, more scalable. Okay, so the architecture diagram I'll provide you about Kafka, and there I'm going to talk more on that. But first, let us consider an example to understand, because examples will immediately touch the concept, and we can easily grasp it first of all whenever we are working with example. That's what intention. Okay, so I would like to take one example here. You take mainly in our ride sharing apps, we'll be having
Sir, what is the meaning of throughput here?
and now let's see. See, you will get an example of understanding this easily. In that only, whatever the question that you are asking, that is also I'm going to cover. Your question is about what is topic, I'll tell you. See, drivers and riders, two people are there mainly. But drivers are going to continuously send they have a GPS installed. Okay, GPS device is there. So through the GPS, their longitude, latitude, okay, their north location, east location. North location is called longitude, east location is called latitude. So their coordinates, GPS coordinates. That is a message that's published for every few seconds. Every few seconds, each driver's driver ID, the longitude, the latitude, and timestamp. Timestamp means date and time, including second. Okay, that information gets published. Continuously will send their GPS locations. Okay. And suppose I am a rider. I am requesting for ride from a current location. Okay, right? So there are thousands of drivers probably. They're constantly sending their updates, their current location for every few seconds. So how to handle these millions of messages that are coming per minute from thousands of drivers? Where should I store and where can I handle them? I need a such kind of highly throughput software or broker is required. Okay, that is where Apache Kafka. That's what I'm trying to say. Okay, you can't see, you can't update directly in the database for every driver whenever the location changes, right? It is a very, very big task. How can you do that? Okay, for every few seconds, the driver's new location, his longitude, latitude, his ID, that current timestamp, everything will come, right? So can you imagine, can we store this type of data in the database? It's absolutely no. Okay, that is going to be a huge drawback. It's a we can say a huge bottleneck, right? So then we need some software, some message server or broker who can handle these millions of messages per minute. And that is where Apache Kafka. There is a perfect fit here for Apache Kafka.
Sir, can you please explain the fault
Now,
tolerance?
fault tolerance, I'll explain next. Fault tolerance means, let's say, for example, they have only one Kafka server where all the messages are getting stored. What happens if that server suddenly goes down or crashed? That's why the messages are replicated. These are replicated onto multiple servers. And the servers are working geographically different locations. Okay, if this server goes down or some
Basically,
earthquake
you mean to
happened here,
say-
flood happened here, then other server can handle because the same messages are available there also. So then
Okay,
that
you
will
mean to
handle
say-
or that will take care of it. So you are not going to lose anything. That's what I mean. It is called making the system more reliable. That's called fault tolerant.
load balancing concept will be used here.
Load
like
balancing
whenever-
is load balancing means that's a different story. Load balancing means if there are
distributing the
many requests are coming,
yeah.
if there is many requests are coming, that's a different story. Load balancing is different, fault tolerance is different. If many requests are coming, and in order to handle them, then you are just going to what I can say, use a load balancer, and through which it is going to find out through an algorithm which instance or which server has less load and will redirect the request to that particular server. That is load balancing. Okay. Here, fault tolerance means load balancing is required when you are expecting more requests. But fault tolerance meaning if by chance if the server goes down, then I should have the messages available so that consumers can come and access them. So that's why we are just going to replicate the same server at multiple places. That we are going to form them like one cluster. If any one message arrived to one server, automatically get replicated to the servers in other locations also, the same message gets there. I mean, it will be synced with there. That is called fault tolerant.
Okay.
Basically, we are replicating Kafka, you are saying.
Yeah. No, that's what I'm talking. Okay. So see, whenever, see, for example, in our use case, okay, there is, let's say, for example, I have created an application called location update. Okay, right? And there is a service like matching service. Okay, and there is something called, see, location update service doesn't know about matching service in the ride sharing applications, because location update service importance is what, whenever any driver sends new coordinates, then simply publish them, store them into one topic. That's it. It is matching service responsibility that consume the driver location and consume the rider location, current location from where he wants to book, pickup location. And now it is going to match, okay, that drivers and riders. Okay, and then we'll send that message to nearby drivers. Then the driver app will be there. The driver app, in the driver app, the driver will get a notification and he may accept or other driver may accept. That's a story. But in this, if you look at overall, there are thousands of drivers. At the same time, thousands of riders are also going to try to book. So these are messages which are continuously getting generated. These thousands of millions of messages per second or per minute. So to store them, okay, we need, and to make it reliable, okay, we need high throughput systems. And that example is what? Kafka. So this is where you guys need to understand why we are going to use Kafka. Okay, that is why Kafka got more importance. And just I want to write now some, because I have explained a lot about why Kafka. Let us have some statements also so that you can refer it when you are going through it. Okay. Right. So RabbitMQ. Okay, RabbitMQ. I can call RabbitMQ as a one message broker. Okay, Apache Kafka also message broker. Both are message oriented middlemen. They are message brokers. So RabbitMQ, what I can say, is a good fit for what I can say, point-to-point messaging. P2P actually. P2P means point-to-point messaging. Means one producer and only one consumer.
Like
I mean to say that
WhatsApp
one
message.
producer has only one consumer, not many consumers.
One-to-one
We
communication.
have any, okay, that is I told already, directly sending WhatsApp message to the friend, particular friend. That's called good fit. So it is good fit for point-to-point. It cannot handle these many thousands or billions of messages per second or billions of messages per day. Okay, just only small. So it's a good fit for point-to-point messaging. Okay. Apache Kafka is a good fit for publish subscribe messaging. These are the two models. This is point-to-point messaging model. Means one-to-one model. Better word, otherwise I can. It's called one-to-one model.
Sir, when this session will end?
Apache Kafka
Sir, when this session will end?
is a good fit for publish subscribe messaging model. Okay.
So what are the content we are going to cover in the 4 days?
Sorry.
Are there any content we are going to cover in the 4 days? This is the 4 days class, right? Workshop, right?
We are getting introduction to Kafka. Why Kafka today?
Okay.
Only Kafka
Sir,
I'm
am I
going to
audible?
cover. Okay. In that why Kafka. Tomorrow I'll talk about Kafka architecture and how Kafka works, leaders, partitions, and all. And next day I'm going to talk about how we can integrate with the Spring Boot. 3 days workshop it is. Okay. Today, tomorrow, day of tomorrow.
Okay. Thank you.
Okay. Yeah. I'm going to explain Spring Boot with Kafka. Not with any general or directly not with the Kafka API with Java, only with the Spring Boot. That's what at the beginning I told. So you need Spring Boot knowledge for this. Okay. Yeah.
Hello, sir.
Now
Sir,
let's
when
move
the
on.
session will end, sir?
It will end in the next 2-3 minutes. I also have
Okay.
next session. So only, oh yeah, I'll take
Yeah,
up
we
to
have a next
8:30,
class,
8:40.
that's why I'm asking you.
Yeah, 8:30 to 8:40. Okay. Next, I also have a session. I need to start the next session. So I'll stop. Okay. So Apache Kafka is a good fit for publish subscribe messaging model. It is called one-to-many model. It is a good fit. Okay. Now this is called the two types of messaging models actually we have. And now we need to understand about why, Kafka, because, in the real-time systems, data is getting generated continuously and applications need to capture this data and they have to perform analysis, okay, in order to improve their business. Okay, so let me write, let's say in real-time systems, like real-time system means your ride-sharing app, your e-commerce app, or suppose you are running one transportation company. You have one, for example, 10,000 cabs, or let's say, for example, 10,000 lorries, okay, transportation lorries. And they will send their GPS locations for every minute or every 5 minutes. Okay, their speed, okay, their engine information, their GPS locations. They are going to send GPS installed, right? Because you should know. Okay, suppose if, for example, one lorry got have a breakdown at some area, then immediately you need to find some alternate so that the goods can be transported as per the agreement. So to give some quick response, right? To give some quick response, we need all these things, right? So you are going to get that information. So you have different applications in the software, receives these GPS locations. Okay, even you'll also get some how many hours this driver has driven the lorry, and so that driver has to be changed. Or you can use some suggestions like route information. Okay, based on the GPS location, for example, you can also suggest the route information that, okay, this heavy traffic area, so just go route this information, like go in this area. You can give some information to the drivers, right? So these are all going to be the part of the messages only. These are all what you are understanding and what you are doing every day, or whatever you are observing every day. They are all internally using this kind of message oriented systems. Okay, so in real time systems, data gets generated continuously, and applications need to capture it and has to process it. Should do analysis and process. Okay, they have to analyze. For example, you take Uber or any ride-sharing app. The matching service first has to analyze: is this a driver is near to this pickup location or far away from the pickup location? It should not send this pickup location to a driver who is 5 kilometers or 10 kilometers away. Okay, if he is nearby surrounding of 2 to 3 kilometers or 2 kilometers at least, so then only this driver should be intimated about this pickup location, so that he may accept the ride or he may reject the ride. That's up to the driver. Okay, that's what. So means some analysis required. Need to capture it and should perform analysis. Right. To improve the business. Okay. So what is required for this? For this, organizations need some what we can say highly reliable, scalable storage systems required first. And the system should support high throughput, means like reading and writing the messages millions per second. Okay, and should have some fault tolerance mechanism. So that is where Apache Kafka came in. Okay, so I'll add 2-3 points so that you'll understand why Kafka and what is this message systems. Okay, So organizations need highly reliable and scalable storage systems. Okay. Second, it should support high throughput. High throughput means reading and writing messages, millions of messages per second. It should allow to read, write messages, millions of messages. That's called high throughput. It should support some, what we can say,
Low latency.
yeah, fault tolerant, no single point of failure. Okay, right? That's what. Okay, that's what I'm saying. So that is where fault tolerant. It should be fault tolerant. Fault tolerant in the sense, no single point of failure. That's what called fault tolerant. Fault tolerant. Anything I can add? Of course, message should be persisted and should be replicated. That's called durable. Okay. It should have durability. It should have durability in the sense, for these organizations need message systems. Okay. Organization message systems. Number one, highly reliable and scalable storage systems. Should support high throughput. High throughput means it should allow reading, writing messages millions per second, and should be fault tolerant, no single point of failure. And finally, it should be durable. Durable in the sense, messages should be persisted and should be replicated. That's what I'm calling it as durability. It should be durable. Okay. So the answer is Apache Kafka. That's what okay, we have discussed for today, guys. The answer for the organizations is, our organization's requirements is Apache Kafka. Hope you guys got with the examples like where Apache Kafka comes in. Okay. Everywhere that you are finding Apache Kafka, I mean to say message-oriented systems. Okay, the best example is our Uber, Ola, Swiggy, whatever it is. Okay, or e-commerce applications, whatever it is. Okay, whenever a customer places an order, first that order will be stored like a message in the middleware. If you place an order, when you click place order on your mobile app, Amazon app, that order is placed as a message in the Kafka broker. Nothing but in like a message in the broker. There is a consumer application in Amazon, and that is actually going to receive the message, will process the message, then in reply it will send that your order is placed. Because at a time millions of at least not millions, thousands of customers can place orders in a peak hours. So that's why they are going to work with Apache Kafka. Okay. So this is tomorrow we will be understanding more on. Tomorrow we'll be understanding more on
Hi,
this
sir. I have
Apache
a small
Kafka.
question.
Okay.
I
I will take up questions. I'll take up questions. Just wait for a minute. So tomorrow we'll be talking about how Kafka, what is producer, consumer, Kafka broker, Kafka partitions, zookeeper, leader, follower, all these kind of things that we are going to look into in the session. Okay, tomorrow we are going to understanding about Kafka architecture. Okay, messages, partitions, topics, leaders, followers, Kafka cluster, zookeeper, how to install the Kafka. These are all the things will be in the session tomorrow. Then we will understand how we can use a Spring Boot to integrate with the Kafka, one Spring Boot application can send messages, other Spring Boot application can receive the messages, can process them. So we are going to look into a Spring Boot application, like how we can send messages to another application through Kafka. Okay, that's what the plan, and that's what we are going to discuss tomorrow session and also in the day after tomorrow session. This is how I'm going to complete this Apache Kafka for you. Okay, now you can, if you have any questions, please let me know. We'll be discussing for 5 minutes.
I have one